So you're asked for the limit as x approaches positive infinity for y and as x approaches negative infinity for y. So in other words, what's happening to the y values when x is getting really, really big, positive infinity? Let's see. So if you do that, think of like what happens if you plug in a billion to help you get an approximation. If you plug in a billion here, this is like a billion over a billion plus 1. That's pretty close to 1, right? So this ratio is getting really close to 1, so 2 minus 1 is going to be 1 here. And over here, if you plug in a billion, billion squared is going to be divided by a billion squared, just plus a measly little 5. So this is getting really close to 1 as well. So as x gets closer and closer to positive infinity, the y values are getting closer and closer to 1 times 1. So that's it. This is 1 for the positive infinity limit. And let's try negative infinity. We got another example coming up, so hang in there if it still seems weird. Negative infinity. So think about plugging in a really small number, like negative a billion. And if you plug in negative a billion up here, well, negative a billion divided by, this is negative a billion plus 1, so that's just slightly less. That's really, really close to just positive 1, right? Here, I can demonstrate what I'm talking about with a calculator. Here's a billion. And I'm going to divide that by negative a billion plus 1, so that's 999,999,000. Oh, I didn't press negative, but a negative divided by a negative makes a positive, right? Look, that's really close to 1. And if you get a bigger number, you're going to be even closer to 1. So this is still 1, and 2 minus 1 gives you 1. So this parentheses is getting really close to 1. And then here, if you plug in negative a billion, it's being squared, so that makes it positive. A billion's being squared here, and I can demonstrate that calculation too. Let's do a billion, see if my calculator can fit it. Square it. Okay, that's the numerator. And so here's the denominator. So let's divide those two. The numerator divided by the denominator. How many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that was supposed to be... Oh, jeez. Okay, well, here's the denominator. Let's do it this way. And then here's the numerator. Did I do a million or a billion? Looks like I did a million. Okay, that still gets the point across. It's really close to 1, right? I plugged in a million. If you plug in a billion, you're still getting close to 1. And they're always going to be positive. You're going towards negative a billion, so if you plug in negative a billion, it's being squared, so it's going to be positive. So this is also 1. Okay, down here, the limit as x approaches positive infinity of y. So you're thinking about plugging in like a billion in here for x. And look, sine of x, that's why we study in pre-calculus, sine of x can only go between negative 1 and positive 1, right? This can only fluctuate between negative 1 and positive 1. And we don't know where it's going to end up if we plug in a billion, but we know it's not going to be that big. 2 times a billion is 2 billion. And so 2 billion plus whatever this is having a minuscule effect because it's only between negative 1 and positive 1. So it looks like we got 2 billion divided by 1 billion. So this limit is approaching 2. And the limit as x approaches negative infinity for y, we're thinking of plugging in negative a billion in here. So this is 2 times negative a billion. That makes negative 2 billion. And again, sine of x doesn't matter what you plug into it. If there's no number out front here, it's got an amplitude of 1. That means it can only go between negative 1 and positive 1. Doesn't matter if you plug in negative a billion, it still cannot have a value greater than 1 or less than negative 1 come out of it. So this is like negative 2 billion. Forget about this. That's becoming minuscule in comparison. Divide by negative a billion. So this is also 2.